Today we're going to be talking about the law of sines and law of cosines. So first we're going to start with theorem 810, which is the law of sines. The law of sines says this: there is a ratio that compares the sine of angle A to side A, which is the same as sine of angle B to side B, which is the same as angle C to side C. And you'll see we can set it up as a ratio or as a fraction to compare them. So if you know either two sides and two angles, or two sides and one angle, one side, two angles, we can use those, the law of sines, to find the missing side, missing value. So example 1 here says find x and round to the nearest tenth. So I see that I have angle C, I have angle B, angle A, and I have side A across from angle A, and I'm looking for side C across from angle C. So I'm going to set it up like this. Sine of A over little a is the same as sine of C over little c. So I plug in the numbers that I know. Well, sine angle A is 97, so it'd be sine of 97 all over 16 is the same as sine of 21 all over c, or x, I guess, which is what we don't know. Okay, well, how do you solve a proportion ratio problem? Cross multiply. And so you get 16 sine of 21 is equal to x sine of 97. Divide both sides by sine of 97. And I go to my calculator, okay, and I type in 16 sine 21 divided by sine of 97, and I find the value of x to be approximately, to the nearest tenth, 5.8. Okay, so you set it up like a proportion and solve out the proportion. Here's 2 guided practice problems you can try as well. So now let's assume, we're going to do the same thing, but this time we know angle, side, angle. So I know a side, but I don't know the angle that it's across from. So we use our information, we use our knowledge of triangles to find the missing angle. Well, angles in a triangle have to add up to 180. So I subtract the angles that I know, 45 and 73. And I find the missing angle to be 62 degrees. So now I know that this 62 degrees corresponds with the length of 10. So I can do sine of 62 over 10 is the same as, and we have to look over at a triangle, which one? We're looking for x, so it's across from angle 45. So I can say sine of 45 over x. And now again, it's just a cross multiplication problem. I get x sine of 62 is equal to 10 sine of 45. I want x by itself, so I divide both sides by sine of 62. I go to my calculator. I do 10 sine of 45 divided by sine of 62, and I get approximately 8. So in this one, we had to find the missing angle to see what it was across from. Here again are 2 guided practice problems. You can try them as well. Now, what if I can't use the law of sines? Okay, I know 2 sides, and I don't know the angles that correspond to them. Then I use what's called the law of cosines. Law of cosines is a little bit more difficult. Okay, so if I'm looking for side A, I know angle A, but I know sides B and C, but I don't know angle A. Okay, and so obviously we can't find this angle and this angle because we don't know what they are. So we can't use the law of sines. So I use what's called the law of cosines. Here's the equation: a squared is equal to b squared plus c squared minus 2b BC cosine of A. Okay, so you'll notice the thing that's important. Okay, A cosine of A. If I'm solving for B, B cosine of B. If I'm solving for C, cosine of C. Okay, so that's what's important to remember from that, and I use all of the sides that I do know as well. So you can use this to solve a triangle if you know the measure of two sides and an included angle, which is the side angle side. So if I look at example 3, okay, I can't use law of sines because I don't know what angle A is, and I don't know what angle B is for their corresponding sides across from them. So what I'm going to do is I'm going to say, okay, angle C. I know angle C, and I'm looking for side C. So I go to the law of sines. Well, the one that was set up for C says C squared is equal to A squared plus B squared minus 2AB cosine of angle C. So I plug in the numbers that I know. Well, I don't know C squared, but I know that A squared is going to be 9 squared. I know that B squared is 11 squared minus 2 times 9 times 11 cosine. My angle is 28 degrees. Okay? So now I can put this into my calculator. I can simplify a little bit easier. This is 81. That's 121. And 2 times 9 times 11 cosine 28. 2 times 9 times 11 times cosine of 28 is the number 174.8. Okay? And so I end up getting C squared is equal to 81 plus 121 minus 174.8. And I get that to be 27.2. Now, that doesn't mean that the side that I'm missing is 27.2. It wouldn't make sense because look, you can look at the picture. It's smaller than 9 and 11. But right now we have 27.2. The reason that is because that's C squared. And the only way to get C by itself is to take the square root of it. So I take the square root of that answer, and I find x to the nearest tenth is going to be approximately 5.2. Okay? Makes sense. Smallest angle, going to have the smallest side, 5.2. Here's a couple examples you can try. So now what happens if I know all the sides and I'm looking for the angle? Well, I set it up the exact same way. Now, you'll see that angle M is across from 8. And just like when we looked at the law of sines, you have to use those corresponding to each other. So that means that this is going to have to be my, let's say, C. So if I look at the same equation again, C squared is equal to A squared plus B squared minus 2AB cosine of C. My C is going to have to be 8 because it corresponds with the angle that I'm using right here. So I plug in the numbers and I get 8 squared is equal to, we'll say A, the smaller one, is 3 squared. B is 6 squared minus 2 times 3 times 6 cosine of x. Now, you might be wondering why I put 3 or 6 in here. And the answer is it does not matter which order you put them in. If I would switch them around, if I switch these two around, it would be fine because multiplication is commutative. It does not matter the order in which it occurs. You'll still get the same answer. So if you would have put 6 squared plus 3 squared, that's still correct as well. So I simplify as best I can. 64 is equal to 9 plus 36 minus 2 times 3 is 6 times 6 is 36 cosine of x. Okay? Now I want these over to the other side. So 9 plus 36 is 45. So I'm going to subtract 45 from both sides. And I end up getting, put it over here, I end up getting 19 is equal to negative 36 cosine of x. Now, I need cosine of x by itself. So how do I undo multiplying by negative 36? I divide by negative 36. So I divide both sides by negative 36. And I find cosine of x to be equal to negative 0.527 repeated. Now, I'm super close. We said anytime you're looking for an angle, you have to use the inverse. So to get x by itself, I do cosine inverse on both of them. Okay? And so I do second cosine inverse on my calculator of that negative 0.527 repeated. And I find my angle x to the nearest degree is going to be 122 degrees. And notice, 8 is the biggest side, so it's going to have a big angle. So that makes sense. Here's a couple guided practice problems. Feel free to try those now. Okay, we can use indirect measurement to find a missing side in a real-world problem. So here in example 5, it says Drew and Hunter are playing basketball. Drew passes the ball to Hunter when he is 26 feet from the goal and 24 feet from Hunter. How far is Hunter from the goal if the angle of the goal to Drew and then to Hunter is 34 degrees? So the nice thing is we have our triangle drawn here. Okay, so this one right here, I know two sides, but I don't know the angles, or at least one of them that corresponds to it. So I can't use the law of sines. I have to use the law of cosines. So I'd say, okay, c squared is equal to a squared plus b squared minus 2ab cosine of angle c. Plug in the numbers that I know. Well, I don't know what c is, but I do know that a, I'm going to pick the smaller one, 24 squared. B is 26 squared minus 2 times 24 times 26 cosine, and I know my angle is 34. Okay? And the nice thing is, if you use your calculator correctly, you can put all of this in. In fact, I'm going to do so now. So 24 squared plus 26 squared minus, and then in parentheses, 2 times 24 times 26 cosine of 34. I find that to be 217.36. Now I need to find out what c is, so I take the square root of both sides. I find that my missing side c is going to be 14.7 feet. 14.7 feet. Here's an example of guided practice you can try as well. Now the last thing we can do is solving a triangle. Now the nice thing is once I find one angle, since I know all three sides, is I can find the other one using the law of sines. So first I look at this, okay, and I say, to solve this triangle, I want to look and say, well, this obviously is not a right triangle, so I can't use the Pythagorean theorem to find it, or my regular trig functions to find it. So I set up the law of sines, and law of cosines. So let's find a first. So I'd say a squared is equal to b squared plus c squared minus bc cosine of a. So I plug in the numbers that I know. 15 squared is equal to b squared is 12 squared plus 13 squared minus 2 times 12 times 13 cosine of a, which I don't know. Okay? So I solve this out. 15 squared is 225 minus 12 squared minus 13 squared is going to be negative 88 right here, is equal to negative 2 times 12 times 13 is 312 cosine of a. Divide both sides by negative 312, divide by negative 312, and I find that the cosine of a is equal to 0.282. So to find what a is, I take the inverse cosine, both sides, and I find that a is equal to 74 degrees. Okay? So now that I know that this is 74, now I can use the law of sines to find the missing one. And I'll pause the video right now to set that up. So you'll see right here, I set up the law of sines. Sine of 74 over 15 is the same as sine of b over 12. You can solve it now to find your missing angle.